Welcome learners to our channel. In this video, we are going to discuss Integrated Science Grade 8, and this paper is designed to help you prepare confidently for your upcoming exams, and it has questions which we are going to explain how to tackle them and also share tips on how to avoid common mistakes. I need you to remember that science is not about memorizing facts. It's about thinking critically and applying what you know. So let's see the first question. The first question, grade 8 learners use their digital devices to search for some uses of common elements in everyday life. Fill the table below using the elements given. So we have been given 4 elements here. The first one is neon, second one is carbon, third one is fluorine, and then the fourth one is silver. So we have been given a use, then we are expected to identify the element which is used amongst the 4 elements that we have been provided. So the first use is that it's used in making toothpaste. In making toothpaste, we use an element which we call fluorine. Fluorine, which is atomic number 9. And the reason why we use fluorine is because fluorine prevents tooth decay. The second use that we have been given is making advertisement. In making advertisement, we use an element called neon. And if you remember, in the periodic table is atomic number 10. Now, the reason why we use neon is because it is bright and it has glowing properties. The third use is making jewel. And the element that we use in making jewel is silver. It's silver. And the reason why we use silver is because silver is shiny and very precious metal. Then the fourth one is to make pencil lead. And the element that we use in making pencil lead is carbon, but graphite. Graphite can be found in 2 crystalline forms, or carbon can be found in 2 crystalline forms. We have graphite and diamond, so we use graphite. And the reason why we use graphite is because graphite is slippery. Then the second question, during a class discussion, Group K members were tasked to highlight properties or characteristics of liquids. List down 4 possible points they highlighted. In this case, the learners in Group K were highlighting the properties or characteristics of liquids. Now, what are these 4 characteristics of liquid that they listed? The first one is that liquids have a definite volume and no definite shape. Liquids have definite volume, so they have a specific volume, but they do not have a specific shape. In this case, that's why liquids takes the shape of the container in which they are placed. The second property is that liquids can flow. They can move from one point to another freely. So in this case, they are fluids. Liquids are fluids. A fluid is a substance that can flow and they can move from one place to another. That's the second property that they gave. The third one is that liquids have surface tension. Surface tension is a force that acts on top of a liquid surface, which makes it to act like a stretched elastic skin, and this is the one which enables mosquito to float on water. Now, all liquids have surface tension, and this one now also enables them to have or to form drops. Remember, if you have water, you can make it fall in form of drops. Is because of surface tension. Then the fourth property that they gave is that liquids are not easily compressed. You cannot compress a liquid easily. This is because their particles are almost close to each other. Therefore, they resist compression. The question, Brian was instructed to put crystals of potassium manganate 7 in water as shown below. So here in this case, we have potassium manganate 7. So the question is, give 2 observations he made after 20 minutes. So before we look at the observation that he made, I want us to look at this setup. So here we have a beaker with a dye. Remember, potassium manganate 7 is purple in color, and any color we call it a dye. If you put that color here, then you have water molecules in this beaker. What you realize after some time, these purple particles or color will spread throughout this container. It will start spreading downwards. Then after some time, it will spread throughout until the water is purple in color. So at that point, we say it's at equilibrium. So one of the observations that they made, or Brian made, was that the water gradually turned purple. So if there was a purple potassium manganate 7 which was placed, after some time, the water in the beaker turned purple. The reason why this happens is because the crystals of this potassium manganate 7 are dissolved and they spread throughout the water, giving it a uniform purple color. The second observation that Brian made was that the color spread without stirring. No one was stirring this liquid, but the color was spreading. This one confirms what we stated in the kinetic theory of matter, that matter, including liquids, are made of very small particles which are in a continuous random motion. So in this case, this motion, we call it diffusion. So in this case, the color spread without stirring because diffusion occurred as the particles moved from a region where they were highly concentrated to a region where they were lowly concentrated. Question 4. Kimani went to a petrol station with his uncle to add pressure into a tire as shown below. So in this case here, we have a tire. Then the question is, the tire looked inflated, but it could hold no air. It could not hold any air. Then the question is, give 3 characteristics of gases that led to this. Before we answer this question, I want us to look at this demonstration of a small video here. So if we have this one as the gases particles, you can see they are not organized and they are everywhere within this container. Now, if you can take a deep look on them, you will see they are moving randomly. And if you can push this container, you will compress them. And if you pull out, then they will spread and occupy any space that you can create. On top of that, if you open or if you cause any opening, even if it's very small, these gases particles, because they are very small and they are moving, they will escape through out of the container. Now this one are going to give us the properties of gases that made this tire look inflated but could not hold any air. The first one is that gases particles are far apart and they move randomly. This one you can see it from the screen. These particles are far from each other, they are not in contact, and they move randomly. Now this makes them compressible, that's why you can compress them, and able to escape quickly when not properly sealed. So if the tire is not properly sealed, they can escape because they are very far from each other and they are always moving. Then the second property is that gases have no fixed shape or volume. You can see these gases particles, they don't have a fixed shape. You cannot tell the shape which they are making. Again, you cannot tell their volume because they occupy any space that you create. So in this case, they spread out to fill any available space. Even a small amount makes the tire fill or appear fully. The reason why this tire appeared full is because the gas particles, even if they were small, they could still occupy all the space which was available in the tire, making it to appear to be full. Then the third property is that gases can escape through even a very tiny holes or leaks. So if the tire had a very tiny hole or a leak, these gas particles could still escape because they are very small and they are always in motion. So question 5, learners use their digital devices to search for the meaning of the word diffusion. If they found the correct meaning, write it down. So in this case, before we can write the meaning of the word diffusion, let's consider this video setup that we have here. On this left side, we have high concentration, of blue particles. You can see there are very many. And then on the right side, we have low concentration of blue particles, because in fact we don't have any blue particles. So if we don't have any blue particle, we say we have a low concentration. Now in this case, if you allow these particles, because we have said gases, particles, or liquid particles are always in a continuous random motion and they are made of very small particles. If you allow or remove this shutter here, which is used to enclose the two sides, you will see the blue particles are now moving from the left side, from where they were highly concentrated, to the left where they were lowly concentrated. But now they will move until this distribution is uniform. Like in this case now, if you look at this, the particles now are uniformly distributed. Now this one gives us the meaning of the word diffusion. We define diffusion as the movement of particles from a region or an area of high concentration to an area of low concentration until the concentration is evenly distributed. Question 6. Grade 8 class set up an experiment as shown in the diagram below. So you can see a diagram here where we have an overflow can, you have water, then you have a stone tied on a thread, then you have a measuring cylinder. So the first question is, state 2 skills that the learners applied during the experiment. So in this case, since this experiment involves handling of these apparatus, then the skill that you need in that case is what we call a manipulative skill. Manipulative skill, because you are handling apparatus. And then another skill that you need in this case, as you can see on this measuring cylinder, we have a scale, so we need measurement skills. You need the measurement skills. Then you are going to see, in this case, then you need observation skills, and many other skills that you can think of. Then the second question, overflow can is also known as this overflow can. What is its other name? An overflow can is known as a eureka can. A eureka can is also called an overflow can, and it's used to measure the volume of irregular shapes. If you have an irregular shape like a stone, you tie it with a thread, then you place it inside an overflow can, which is filled to the brim at this point. The volume that it will displace will be the volume of the stone. Remember, a stone is shapeless and you cannot use any formula to calculate its volume. So in this case, you use a method we call a displacement method, and we use an apparatus we call a eureka can. So an overflow can is also known as a eureka can. Then the third question, liquid X, this liquid here, collected represents the stonies. This liquid X represents the stonies volume. So this liquid which is collected here is equal to the volume of the stone, because at the beginning the water was full to this brim. When you place this stone inside, this stone displaced some water. It occupied that space. The water which was displaced went into this measuring cylinder. So the volume of water which went to the cylinder is equal to the volume of that stone. Question 7. McKenna's teacher used two symbols. What is their meaning? The first symbol in this case represents a forward process, and then the second one represents a backward process. Now we use these two symbols most of the time when we are representing a physical change. For example, if you have ice which is in a solid state, if you heat it, it will change to water which is in liquid state. So in this case, for you to indicate a forward process, you have to use that half arrow. In this case, when you are heating. Then now, if you cool this water, it will change to ice. In this case, this when you cool. So this one represents a backward process. So it shows that this process is reversible. Then question 8, Quinoa saw salt being added on snowy roads in Europe. Explain the application. So you can see on this photo, in Europe, when it is in winter, there is a lot of ice on the roads because the temperatures of water are below 0 degrees. So in this case, this ice, since it's in solid state, it blocks road or vehicles from moving smoothly. So for you to do that, you have to add salt. Now, why is salt added? Remember when you discussed in grade 7 about impurities, you said impurities lowers the freezing point of substances. So in this case, when salt is added, it lowers the freezing point of water. This process is called freezing point depression. Now this one prevents ice from forming at 0 degrees Celsius, and it helps in melting the existing snow, which is ice, into a liquid state. And this one now clears roads and for easier navigation. Then question 9, a pure substance made up of one kind of particles that cannot be broken down into a simpler substance is known as, let's look at the question again. A pure substance made up of one kind of particles that cannot be broken down into a simpler substance is known as, this is a definition of an element. An element is a pure substance that cannot be broken down by any simpler mean or into any simpler mean by any chemical process. Then B, give 4 examples of such substances that cannot be broken down by any chemical mean. So in this case, you can list any of the 20 elements that you studied. So in this case, you can say one of the example is hydrogen. You can give another example as oxygen. You can give another example of a metal like sodium. These are elements. You can say we have sulfur. You can say we have calcium. We have magnesium. So any element among the 20 elements, you can just list them and they will be answering your question. Elements are pure substances which you cannot split into any simpler mean by any chemical process. Question 11. Table salt is also known as dash. So in this case, what is the other name for table salt? The other name for table salt is sodium chloride. Sodium chloride, its chemical symbol is sodium chloride, a substance which is formed when sodium reacts with chlorine. Then question 11, when mothballs, do you know what are mothballs? We have them here on the screen. These are mothballs. When mothballs are kept in the open, they change directly from solid to dash in the process called dash. So in this case, when you have these mothballs and you keep them in the open, they change from solid to gas directly. And this process is known as sublimation. Now, we can demonstrate this one by a very simple equation here. We have a solid. We have a solid here. Solid changing in a forward process to a gas, and then in a backward process changing back to solid. So in this case, the process where a solid changes to gas, we call it sublimation. And then where a gas changes back to solid, we call it deposition. Deposition occurs when you cool, then sublimation occurs when you heat. Now, apart from mothballs, we have very many substances which undergo this process. One of it is what we call dry ice, which is used by ice cream vendors. The other name for dry ice is solid carbon dioxide. Then another substance which undergo the same process is iodine. Another substance is what we call iron 3 chloride. We also have ammonium chloride. We have another substance called benzoic acid, and many other substances which undergo sublimation and deposition. So if you are asked to list these substances, don't forget the list that we have given here. Question 12. The chart below on changes of state of matter was displayed by learners during a group discussion. So in this case, we have process A, where you have liquid to gas. This one is called evaporation. And then we have B, where you are having a solid to a liquid. This one is melting. And then we have process C, when you have a liquid to solid. In this case, we call it freezing. And then we have process D, when you have a gas to liquid. When you have a gas to liquid, this one we call it condensation. So now the question is, name the processes A, B, C, and D. So in this course already we have named them. A is evaporation. B is melting. C is freezing. And then D is condensation. Like that. Then question 13. During a practical lesson to investigate a certain property of solids, learners put 100 cubic centimeter of water in a cylinder as shown below. So you can see we have a cylinder, measuring cylinder. We have a string tied to a stone. Then we have a working surface. We have water, and its original volume is 100. So initial volume of water is 100 cubic centimeter. Then now, after dipping in the stone, the new level of water is 135. So the final volume after dipping the stone is 135 cubic centimeter. So this one is for stone plus water. Initial was just water only. Then now the question 1 is, what is the volume of the stone? For you to get the volume of the stone, what you do, you will take volume of water plus stone, then subtract volume of water alone. So in this case, what you do, you take the final volume, which is 135 cubic centimeter, then you subtract 100 cubic centimeter. And here, you will get the volume of the stone as 35 cubic centimeter. Then, question 2, the practical activity was to find out if the solid have a definite, in this case it's a definite volume. Question 14, grade 8 learners set up the activity shown below to heat copper 2 sulfate crystals. When you talk about crystals, it means this substance contains water of crystallization. So in this case, you can see this setup. We have a Bunsen burner. Then we have copper 2 sulfate crystals. We have said this one contains water of crystallization. We have a retort stand. We have a boiling tube. We have a clamp. We have a stopper which is covering this boiling tube. We have apparatus W. We have a apparatus X. We have a beaker. Then we have this beaker containing ice cold water. And then we have a colorless liquid inside this apparatus X. So let's go to the question. Name the part marked W and X. Part marked W, remember this apparatus is used to deliver the vapor generated when you are heating copper 2 sulfate crystals into this apparatus X. So since this one is used to deliver the vapor, it's known as a delivery tube. This one is a delivery tube. So this one W here, we call it a delivery tube because it's used to deliver substances, especially in gaseous state. Then now, can you name apparatus X? This apparatus X is a test tube. This is a test tube. But again, since it's not so clear because it's a drawing, you can call it a boiling tube. You can call it a boiling tube and you will not be wrong. You will get your marks. Then question B, which color was copper 2 sulfate before heating? And then what is the color change when it was heated? So in this case, before you heat copper 2 sulfate, before you heat, it's blue in color, or it is in blue crystals. And when you heat, it changes to a white powder. Then when you add the water into this white powder, it changes back into a blue crystal. That's why we have these arrows. Remember, we discussed them earlier and we said this is a forward process and then the other one is a backward process. So this process is reversible. So in this case, the color before heating is blue. Let me write using blue, is blue, and then the color changed to a white powder. So in this case, it changed to a white powder. When it was in crystals, it is in blue, and when after heating, it changes to a white powder. Now, the kind of change observed above is this kind of change where when you heat, water is lost. So in this case, there is change in mass. But this process, if you add the water to the substance which lost the water, the reaction is reversible. So we call it a temporary chemical change. Temporary chemical change. A change where a substance undergoes a chemical process, like in this case, there's loss in mass, but when you add back that in an equal amount of water, it changes back to its original color and shape. That is a temporary chemical change. Then another question, Omondi, a grade 8 learner, used a digital device to search what happens when potassium manganate 7 is heated. It forms a black-green solid and produces a colorless gas, being a chemical change. In this case, we have potassium manganate 7. When it's heated, it forms a black-green solid and then it produces a colorless color. Then the question is, give 3 characteristics of this change. 3 characteristics of a chemical change. So the first one is that in a chemical change, a new substance is formed. This new substance in this case is a black-green solid and also a gas which is produced. These are new substances because the original substance was potassium manganate 7. Then another characteristic of this process is that the change is irreversible. This change, you cannot return it back to its original position. So this substance, once you heat potassium manganate 7, a gas is lost, the gas escapes into the atmosphere. There is no way you can capture that gas and bring it back. So in this case, the change is irreversible. You can never reverse it back. Then another property is that there is change in energy. Heat energy is absorbed or released during the reaction. When this process is taking place, remember, for potassium manganate 7 to lose a gas on and again form a new substance, heat was introduced. And in this case, they are telling us heat was introduced. So in this case, there is absorption of heat or there's a release in heat during the process. Then question 16, elements are often represented by letters. The name or the letters are referred to as the letters which are used to represent elements. What is their name? They are called chemical symbols. Chemical symbols. A chemical symbol is a letter which represent the name of an element. For example, if you have sodium, its symbol is Na. So this is a chemical symbol. If you have calcium, which is atomic number 20, its symbol is Ca. So this is a chemical symbol. If you have atomic number 6, which is carbon, then its symbol is capital C. So these symbols which represent the name of the elements, they are known as chemical symbols. Then question 17, Group C members prepared a chart showing elements and their symbols during their integrated science lesson. Complete by filling it or by filling in the table below. So here we have an element and then we have a symbol. The first one, we have a symbol which is A, capital A, small g. What is the name of that element? This one is silver. This is silver. The chemical or the Latin name for silver is argentum, which is written like this, argentum. So the chemical symbol, we get it from the first letter and the third letter, which is Ag. Then the second symbol in this case is this symbol you can see here, which is A small u. A small u represents an element we call gold. Gold, the Latin name, this argentum we have said is the Latin name for silver. So we also have gold. Gold, the Latin name is aurum. That is the chemical name for gold. So we get the chemical symbol from the first two elements. Then the third substance we have here is a chemical symbol which is capital A small l. So in this case, the symbol or the name of a chemical of an element with a symbol capital A small l is aluminium. So this one is aluminium and we get it from the first two letters. Then the fourth one is an element called copper. The chemical symbol for copper is capital C small u. And this one we get it from the Latin name. These are Latin names. So we get it from a Latin name of copper, which is cuprum, where we get this symbol is for copper. So we get it from the first two letters of the word cuprum from the Latin name. So in this case, the symbol for copper is Cu. The chemical name of or the name of an element represented by Al is aluminium. The name of an element represented by Au is gold from the word aurum for gold. Then argentum, that is a silver represented by Ag.